Hello, welcome you all. In this session, we will see the new model, that is heat transfer. Heat transfer, it is one of the important fundamental subject for most of the engineering branches. As a mechanical engineer, we are interested in the mechanism of the heat transfer, design of thermal equipments, and calculating the thermal stresses and the distribution of thermal stresses. In this video session, or in this subject, we are finding the finite element solution for the thermal problems. Okay, let us start with the basic equations. The basic equations of the heat transfer, that is energy balance equation and the rate equations. What is energy balance equations? For the given body, what is the energy entering into the system plus what is the energy generated in the system? Okay, that should be equal to what is the energy leaving the system and what is left in the system, that is internal energy. Okay, this is the energy balance equations of the heat transfer. Okay, here the equation is given where EIN, it is energy inflow into the system, energy generated in the system, and it is the energy outflow from the system, and it is the energy what is left in the system, that is internal energy of the system. So energy balance equation, it according to the law of conservation of energy, what is the energy it is into the system plus what is energy generated in the system, that sum it is equal to energy leaving the system and what is the energy left in the system. Okay, this is the energy balance equation. And we already know that there are different modes of heat transfer. First one is conduction, second one is convection, and the third one is radiation. In the conduction, the heat transfer will take place without any movement of the masses. The heat transfer is atomic level, from one atom to the another atom. So such a heat transfer, it is called as the conduction. The rate of heat flow or the rate equation, it is called as the Fourier equation. Okay, it is for one direction, where Qx, it is the heat transfer rate, the rate of heat transfer, that is equal to K into A into dt by dx, where dt by dx, it is the temperature gradients. Always the heat transfer takes place when there is a temperature difference is there. Okay, where K is the thermal conductivity, it is the material property, and A is the area, and dt by dx, it is the heat gradient. It is one of the heat transfer, one of the mode of heat transfer, conduction. And in the convection case, the heat transfer takes place between the body and the surrounding. Okay, such a type of heat transfer is called as the convection. Okay, the rate equation, it is given by Q is equal to HA into T minus T infinity, where Q is the convection heat transfer rate and H is the property of the material, that is temperature it is convection heat transfer coefficient, and A is the area, and T is the temperature of the body, and T infinity, it is the surrounding temperature. Okay, where the heat transfer between the body and the surrounding. Similarly, radiation. In case of radiation heat transfer, it is the thermal energy, it is exchange, the heat transfer between two bodies, exchange between, in the absence of media, there is no media present in case of radiation. Okay, the rate equation, it can be given by Q is equal to sigma epsilon A into T raised to 4 minus T raised to infinity raised to 4. Okay, where this is this sigma, it is the Stefan-Boltzmann constant, and epsilon, it is the emissivity of the surface, A is the surface area of the body, and T is the temperature of the body, and T infinity is the temperature of the surrounding media. Okay, these are the three modes of heat transfer, that is conduction, convection, and the radiation. In this video session, we have seen the energy balance equation and the rate equations.